Have you heard that maybe you shouldn't try a low carb or a keto diet because it'll raise your LDL cholesterol or your so-called bad cholesterol? Or maybe have you had a genetic profile done and the report says that you have a genetic mutation or genetic SNP that won't allow you to process fat well, and that you're more likely to get diabetes or high cholesterol or some bad outcome from dietary fat? If you had, then this is the video for you to help clarify this. I'm Dr. Brett Scher, the medical director at dietdoctor.com. And in this video, we're going to get to an interview with Dr. Lucia Aronica. Now, Dr. Aronica is a researcher and a professor at Stanford University, and she recently has had three papers that really apply well to this topic. One is looking at the different genetic variants that can affect your response to a ketogenic diet. And at first, like I said in this interview, I was a little concerned this was going to be way high level and talk about these esoteric genetic defects. But really, no, she does a great job. She and her co-authors, which is an all-star cast of Jeff Volek and Angela Poff and Dom D'Agostino, they do a great job of really showing what are the most pertinent genetic variants and which ones maybe don't apply. And they do a very good job differentiating between an obesogenic high-fat diet and a ketogenic diet. And they're very different. And what applies to one likely does not apply to the other because they're two different physiologic situations in your body. And unfortunately, the genetic reports we get now focus on the obesogenic high-fat diet, not on the ketogenic diet. So this is an important paper to differentiate between those two. But then the other part is, what actually happens to your LDL cholesterol when you're on a keto diet? And we've seen reports from different doctors or cardiologists that say you should not go on a keto diet because it raises your LDL cholesterol. But we have evidence that in the majority of the people, it doesn't. And now Dr. Aronica, along with her colleagues, Dr. Christopher Gardner at Stanford and others, have published a secondary analysis of the dietary fits trial, which compared a healthy low-fat diet to a healthy low-carb diet. And what they found was no matter how much saturated fat you ate or how much dietary cholesterol you ate, it did not raise your LDL cholesterol within that context. So two very important studies that combined show that we shouldn't make assumptions about how somebody's going to respond to a certain diet, especially when the evidence to support that is fairly weak or being extrapolated from other variants of a diet. But instead, we need specific studies evaluating a specific diet, and we can always just test it in somebody to see how they actually respond. So that was sort of my take home to these two studies that we'll link to. And now we have the benefit of having a special one-on-one interview with Dr. Lucia Aronica to hear her take on these studies that she participated in. Dr. Lucia Aronica, it's great to have the opportunity to talk to you again. Welcome.
Thank you for having me, Brett. It's always a pleasure.
Yeah, of course. And you've been busy. You've had a number of publications recently that are pretty exciting. So I'm glad we have the opportunity to talk about them. So the first one was like an all-star low-carb team here with yourself, Dr. Jeff Volek, Angela Poff, and Dom D'Agostino. So some big names in the field. First, that must have been a pretty fun project to work on with them, I imagine.
Yeah, it was an honor and a pleasure, really. It was wonderful.
So the title of this one is Genetic Variants for Personalized Management of Very Low Carbohydrate Ketogenic Diets. And I've got to be honest, when I first looked at it, I thought, this is going to be like so high level genetics. I wonder if it's really going to reach people and apply to people. But then as I read through it, I was really impressed because you weren't just talking about specific sort of esoteric genetic markers that may or may not impact a ketogenic diet, but you're also talking about sort of more common markers that are maybe used inappropriately to say a ketogenic diet won't work. And I think that's so important because now with how ubiquitous genetic testing is with 23andMe and other types of companies, people get this laundry list of genetic SNPs that they may have or mutations that they may have. And it may say, because you have this one gene, you will not respond well to a high-fat diet. And that can be really confusing. People will say, well, wait a second, I can't do a ketogenic diet because of my genetics. But your paper sort of goes through that. So tell me like what your take-home messages sort of from this paper are that people can learn from to say, okay, well, here's how I can use this genetic information to help me understand what's right or maybe not right for me.
Thanks for providing such a great summary of, of the study. So I worked on this paper with Jeff Folek, Dominic D'Agostino, and Angela Poff. And I think the most important contribution is that we provide a roadmap of what we know and what we don't know about how genes can affect the response to a ketogenic diet. And this is, I think, extremely helpful because people are confused. Scientists are confused. The doctors are confused, and the general public is confused about this topic. And so, first of all, we describe that yes, genes can affect the way people respond to a ketogenic diet by modifying the way we metabolize carbohydrates and fats. But most of the genetic variants that we know so far are very rare genetic variants. So, like 1 in 1,000 to 1 in 1 million and less. And so they are not relevant for the general public. And some of these variants are a contraindication for a ketogenic diet. For example, variants that cause defects, inborn defects of keto metabolism or fatty acid oxidation. But other rare genetic mutations are actually an indication for a ketogenic diet. An example is the glucose transport 1 deficiency syndrome, or GLUT1 deficiency syndrome, which is caused by a defect in glucose transport that can be bypassed by a ketogenic diet, which is the first line of therapy. And I know you have on your website some nice videos about how to manage glycogen storage diseases with a ketogenic diet. So these are other genetic variants that are an indication for a ketogenic diet. And also drug-resistant epilepsy. We know that the ketogenic diet was first used to treat those conditions, and those are also associated with some rare genetic variants. Now, this is what we know. What we don't know and still we need to learn a lot about is how the common variants that people are talking about in the media actually affect the way we respond to a ketogenic diet. And here there is a lot of confusion. The problem is that, for example, many genetic reports commonly but misleadingly list some genetic variants, such as those in the PPAR alpha genes that are associated with worse lipid outcomes in the context of high food intake and high carbohydrate intake. These diets are called obesogenic high fat diets, or OHFDs, and the effects of OHFDs are diametrically opposite to those of a ketogenic diet. So these variants are actually not useful to predict whether your LDL is going to go up or on a keto diet, and whether this matters at all. So in that paper, in table 1, you can see that we really focus on only a bunch of variants that have been associated with a differential weight loss response or body composition response in people that do a ketogenic diet in a clinical trial of the people actually did a ketogenic diet. And also a couple of variants that have been associated with a differential neurological response, so improvement in cognition in response to acute administration of exogenous ketones.
Yeah, I think that's so important how your paper differentiates the obesogenic high fat diet versus a ketogenic high fat diet. Because when you get a report, your genetic report, that report isn't going to make the differentiation. It's going to treat all fat the same, whether it's an obesogenic high fat diet or a ketogenic diet. It's going to treat all fat the same, which, as we know, the body physiology doesn't treat it the same in each situation. And so the genetics may not apply. But then we have to be honest that there's a lot we just don't know about how these genes will apply to a ketogenic diet. So it's good that you're very clear in this paper what we know and what we don't know. Now, if you were going to pick one gene that's probably the most helpful to say whether or not you will respond well to a ketogenic diet, is there one that stands out for you? Or is that too simplistic to try and pick one?
I think it's too simplistic. Actually, in that table that I mentioned to you, and people can go and look at the table. We strive to make things simple and really even highlight the role of those genes in metabolism. So we provide a strength of evidence score for each of those SNPs. So what is the evidence? And we calculated that score based on the number of studies done in humans, clinical trials, and how many people were enrolled. And none of those SNPs reached the top score. So they are still possible. And that's why in this paper, we suggest that those variants should actually be tested in larger studies. So these are
Mhm.
the first steps. We think that those are more candidate genes. Clinicians can start to test those genes in their practice, but more as a one of the many pieces, one of the many biomarkers they test in the context of a ketogenic diets, and so they can also help advance the field. This is really a paper that is also a call for action. Let's define
Yeah.
what is a ketogenic diet, what is not, and then let's involve also more a clinical researcher, and let's focus on what we know and build on that, and also what we don't know and do other studies. For example, I mentioned that there are very rare diseases, so inborn conditions of defects of keto metabolism associated with rare mutations, but the same genes also carry some more common variants that have been already associated with the differential metabolic traits in the population. It would be very exciting to test those common variants in the context of a ketogenic diet. And we provide also a list of those exciting candidates for future research.
Yeah, very interesting. Well, and the tables are very helpful. So anybody who's interpreting their genetic report should have that table next to it so they can compare and have a cross reference. I think that'd be very helpful. But one of the genes you mentioned, specifically the PPAR alpha, and some others, have to deal with cholesterol metabolism or LDL cholesterol rising with a high fat diet. And that is also really important because one of the big knocks about a low carb or keto diet is, oh, it's so high in saturated fat and cholesterol, your LDL is going to go up, especially if you have one of these genetic variants. Your LDL is going to go up, so you shouldn't try it. At least that's what some doctors say. But then you have another paper out, this one with Dr. Christopher Gardner as part of the Diet Fit study, specifically looking at the change in cholesterol concentration, LDL cholesterol concentration in the body, as it compares to cholesterol intake for those following a healthy low carb diet versus the healthy low fat diet as they're defined in the Diet Fits trial. And this one I thought was so interesting because it shows the importance of testing, not assuming. So many doctors will assume, either based on genetics or simply based on the dietary makeup, that it's going to adversely affect LDL. But that's not what you found. So tell us a little bit more about this study that you did as well.
Yes, this is a hot of the press study. We published that last week. And this was a team effort. So I really want to thank fabulous co-authors, especially the lead co-author, Monica Vergara, a brilliant MD candidate at Tulane University, and Christopher Gardner, who has supervised the study. And so in this study, we looked at the 208 low carb dieters within the Diet Fits study at Stanford. This was a study where a randomized clinical trial with 608 people were randomly assigned to either a low carb or a low fat diet for 1 year, and both diets focused on whole foods and reduction of added sugars and refined grains. So we focused in this analysis on the low carb dieters who increased their cholesterol consumption over a period of 12 months. And specifically, then we looked at three groups. So the first group who increased the least their cholesterol intake, up to the third group, which increased their cholesterol intake the most. And in this third group, actually, people ended up eating on average 700 milligram of cholesterol per day, which is more than twice as much as what was previously recommended. I think the previous upper limit was 300 milligrams per day. And then we actually we found that an increase in dietary cholesterol in the context of a low carb weight loss diet was not associated with an increase in blood cholesterol. And even after adjusting for confounding factors such as the baseline dietary cholesterol intake, age, gender, even saturated fat and weight loss. In addition, we also observed a trend for actually lower triglycerides and higher HDL with a greater intake of dietary cholesterol. So overall, we believe these findings are very relevant for public health, because this means that eating more cholesterol is not necessarily bad for you, and actually in the context of a whole food low carb diet can even be beneficial, because we did see an overall improvement in blood lipids. And this analysis really parallels um, another study that we published a couple of years ago with saturated fat. So we did the same. We look at the low carb dieters who increase their percent consumption of saturated fat. And even there, we saw that the greater the increase in percent intake of saturated fat, the greater was the improvement in overall improvement in blood lipids in terms of reduction in triglycerides, increase in HDL, and the LDL was not affected even there.
Yeah, so great to have both of those studies, one looking at the saturated fat and one looking at the dietary cholesterol. An important caveat that this is in overweight participants undergoing a weight loss trial. So we know we've heard a lot about lean mass hyperresponders or just hyperresponders in general, and they definitely do exist. But what studies like these that you did show so clearly is that it doesn't apply to the majority of the people. The vast majority of the people who are engaging in a higher saturated fat or higher cholesterol, low carb diet for weight loss do not see the rise. And I think it's really important that you clarify the context of the diet, right? Because this isn't a caloric excess, high carb, high fat diet, which is what most of the studies of the dangers of saturated fat or the effects of dietary cholesterol have been in. And this is in a completely different context that's so important. That's why it contributes so nicely to the medical literature. Were you surprised at all by these findings, or were they sort of what you expected?
No, I wasn't surprised at all, and I think most of us in the in the low carb world probably are not surprised. But I think it's important to emphasize what we just mentioned, that these results may not apply to everybody. So the weight loss does affect blood cholesterol. Actually, during rapid weight loss, blood cholesterol can go up, and during slow weight loss, it can go down, and that's why usually clinicians don't look at cholesterol when the weight is changing rapidly. And also, this was a whole food diet, and people were healthy, didn't have diabetes. So I think what's really important here to point out is that it would be great to do more studies like this in different populations, um, who have individual who have, for example, underlying insulin resistance or diabetes may respond very differently, and then different foods like a whole food ketogenic diet versus a diet full of processed meat, or I think all these factors can also affect this association.
Yeah. Yeah, that's a great point. So when are you going to do that study? Are you working on that one?
No, but I'm working on so many studies, and thank you very much
Yeah.
for giving me here an opportunity to talk about these studies. I still, I have many projects at Stanford, and I would love even to collaborate if other academic are listening. We still have the epigenetic data that we are resuscitating now after focusing on these. On these blood lipids studies, and many more to comes. I even enjoy just contributing to these communication efforts, and I thank you, Diet Doctor, for doing such a great job. Really, it's so important.
Well, thank you. Thank you. But we couldn't do what we do without the fantastic research that's being done. So thank you for taking part in that and for sharing all your wisdom and your insight with us today. And we look forward to hearing more from you. And next time you have a paper published, please come on back and let's talk about it some more.
Thank you. I will. I certainly will. Thank you.
All
Grazie.
right.